everyone, I'm glad to see you. I'm Ash, and I want to work with you on an engineering project. But first, I want to tell you a story. Once there was a rabbit who was really proud of how fast he could run. He was always telling the other animals, "I am the fastest animal in the forest." One day a turtle got tired of all his bragging, and she said, "I bet I could beat you in a fair race." "You've got to be kidding! You'd be eating my dust for weeks," the rabbit said. He wasn't a very polite rabbit. And the turtle said, "I said a fair race. I'm not as fast as you, but I can think as well as you. Let's both make a race car, and let's see who can go the fastest." The other animals all agreed this was a great idea, because they were secretly tired of the rabbit bragging too. So the turtle went home and looked around in her garage and thought about what materials she had to use. She gathered some cardboard and some plastic lids and some rubber bands and a balloon and decided to design her race car. So she made a model and she made a racetrack, and that was she tried a 10-foot track and tested her model, timing it to see how fast it went. After she was finished, she looked at her data she collected and she thought, "I think that this was a good model, but I think I could do better. Maybe I should consult with some other engineers and get some feedback." That's the part where we are gonna make our own prototypes. We're gonna see if we can help our friend the turtle. So the first thing you guys are gonna need to do is to get some materials. For our first prototype or model, we want to be using pretty much the same materials. So we're gonna gather some light cardboard, maybe something like a cereal box or some other light cardboard. I have a little French fry box type thing here. We're gonna want some rubber bands. We're gonna want some masking tape. We're going to want a balloon, some twist-off lids, or you could, well, let's start with twist-off lids to start. We're gonna want some scissors, a hammer, a big nail, or I have a threaded screw here, some straws, and you'll want some kind of a thin material to use as an axle. I've got 2 skewers. If you don't have skewers, think about what kind of thin material you could use to hold your wheels onto your vehicle body. So the first thing I'm going to do is draw a little design of my vehicle. So I've just got some paper here, and I thought I could make my vehicle more aerodynamic. So I cut my French fry box. Kind of along the sides, and I made it pointy in the, I think I'm going to make it pointy in the front, kind of like a boat or a paper airplane. And I'm going to kind of make it thin, and I'm going to maybe tape the edges a little bit. And then I was thinking I could put my skewers inside my straws and attach them to my wheels on the side. So my design kind of looks a little bit like a turtle, even if we think of this as the head. So I'm gonna put this together and then we'll test it and see how well it does. So you can just do a basic sketch. It does not have to look beautiful. So I've already cut my box, and I'm just gonna tape it down so that the front is really pointy. So we're just gonna make it kind of sharp and pointy in the front, because my prediction is the air is going to flow past the front side, and I think we're gonna get less friction or air resistance if we make the front of our vehicle sharp and pointy. You don't have to make your prototype this way if you don't want to. You can try your own ideas. And we all want to try some different ideas so that we can compare our ideas together and see maybe some other people came up with ideas we never thought of before. So I kind of have a paper airplane made out of cardboard. Then the next thing I'm going to do, I'm going to put on my safety glasses because I want to make some axles for my vehicle. And I'm just going to measure my axle against the body of the vehicle. But if you like to measure things very accurately, you can use a ruler. And I'm just going to kind of cut a little bit into my skewer with the scissors, and then I'm going to break it. Like that. Then I'm going to measure the skewer against the remainder of the skewer, and I'm going to do the same thing. So I want to make sure I have my eyes protected just in case any little part of my skewer flew up in the air. I didn't want to get hit in the eye. Next thing I'm going to do, I'm going to slip my axle or skewer and measure it against the straw. And I want my straw to maybe be a little shorter than my axle. So we're going to go like that. And we'll go like that. And the reason why I'm going to slip my axle into the straw is because I want my axle to be able to freely turn. And if I were to attach it to the bottom of my vehicle, just as a stick, it wouldn't be able to turn. So I'm just going to attach my axles and my skewers to the body of my vehicle using tape, since we're just prototyping here. For a prototype or a model, we don't necessarily need to make it look beautiful, because what we want to do is see, we might be making some changes. So we want to see what works and what doesn't work. So I just want to securely tape my straw down. Because I don't want my wheels to come off my vehicle. Now you might notice my prototype does not have a motor, because we aren't going to be using an engine to power our prototype. We're going to be using air. That's what the balloon's for. So in a minute we're going to have to think about how are we going to get that balloon attached to our vehicle. First I'm going to attach the wheels, and hopefully I didn't make my holes in my lids too big. I want the lids to stay on pretty tightly. So I already had cut some holes in these lids, and I'm going to show you what I did. And I might have to put a little drop of hot glue on here and fix the holes if they're too big. So what I'm going to do is just take my big threaded screw and my hammer. I'm just going to kind of nail it right in here. Just like that. I'm going to just push it right onto the skewer. And I'm going to go ahead and add just a little drop of hot glue, because I think I might have accidentally made the holes too big in these two wheels. So we're just going to put a little drop of hot glue on there and then put it through the skewer. Why do you think that we don't want our holes in our skewers, in our lids, to be too big? What would happen if your wheel on your car wasn't attached the right way? If it wasn't securely attached, your wheel might come off your car. And if we're in the middle of a race, we really don't want to lose our wheels. So we're just gonna push the skewer through. Make sure that my axles can turn freely. And so I have a very lightweight little car that I think is gonna go pretty fast because it's so light. And the last thing I have to do after I get all the hot glue off my hand is don't do that part. You don't want to get hot glue on your hand. Last thing I want to do is figure out how I'm going to attach my balloon that's going to make our car go. So you put, fuel into the tank of your car, or maybe you have an electric car that runs on electricity. We're gonna make an air power car. And so I'm thinking I can probably make a tape loop and attach my balloon to my car that way. And the only problem is this is going to be a little bit of an experiment because my balloon might just fly off the car. So if that happens, that's okay because we can always change our design. So I'm just going to put a little tape loop, going to blow up the balloon. So I've got a pretty good amount of air in my balloon. I'm gonna have to hold the neck of it shut until we take our car over to test it on our racetrack. So let's go and test out the car. Okay, so now we're going to test our prototype. You guys might notice I've already made some changes to our initial design. My initial design, I thought that maybe the axles weren't long enough. So I went ahead and I used a full-size straw and a full-size skewer. And I also noticed my first design was a little bit flat. So I made it a little bit thicker and I added a little holder for my balloon. We're going to see if we're going to be able to make this prototype go and how long it takes. You can use a stopwatch or you can use the stopwatch function on your phone. I'm going to use my phone's stopwatch function. So I'm just going to get that ready. So now I'm going to put my car at my starting point, measure off 10 feet, and we're going to see how long it takes our car to go 10 feet. If you have a friend, it can help to have them operate your stopwatch and help you with your timing, but if you don't, you can do like I'm doing. All right? Ready, set, go. So, we're still having a problem. I've already gone to 8 seconds, so I'm going to stop my stopwatch. Can you tell what the problem is? Our balloon is hanging in the holder and it's not releasing enough air. So, I want to play around with this design more, but I also want to show you a design that works. So I have another design here. What I'm going to do is I'm just going to take my balloon out of its little holder. Or I'm going to actually start with a new balloon. And we're just going to demonstrate how the balloon's going to push the car. So this car isn't as aerodynamic, but what I like about it is it has a little place for you to put the balloon. That's already a built-in holder. You have to hold on to the neck of your balloon so you don't lose all your fuel. I reset my stopwatch, and we're going to let the balloon go and see what happens. Ready, set, go! Then we're going to let our vehicle go to a complete stop, and we're going to see how long it took to get to that stop. My vehicle was able to go this far in 5 seconds. And the floor here is a little bit rough, so I think on a smoother floor we could probably go the whole 10 feet. about 7 feet estimated. So what you would do is you would grab your ruler or your measuring tape, you would measure the point between where your car stopped and the finish line. So our car went, we'll say 7 feet, but what we really care about is the time. So it took it 5 seconds. I'm going to put on my data table, design 1, that took forever. That one didn't even really move more than about 1 centimeter, and it took 7 seconds. So what you guys would do with your data table, you would be making some changes to your design and you would be doing some new tests on your first prototype. I went ahead and I showed you 2 prototypes. So remember, for your design and your data sheet, you're going to fill out each test. So prototype number 1 went about 1 inch in 7 seconds. Prototype number 2 went 7 feet in 5 seconds. And what you do at home, remember, you're going to try more than one test with some different modifications. This is just an example to show you how to use your data sheet. Now, let's head on back and I'll tell you how we're going to finish up this project. All right, so we tried our prototype and we noticed that we needed to make some changes. So we made some changes and tried again. This is what you're going to do when you make your design. So you're going to make your first design using the materials that we started out with. You're going to test it, write down your distance and your speed on your data table, and then you're going to make some changes. You'll test it again. Make sure you record the second distance and time on the data table. And then I want you to make one more set of changes. So we want to see what's the best design we can do. So once you've got everything recorded on your data table, you'll have a little engineering report to fill out so that when you talk to your other engineer teammates, you guys can compare what worked, what didn't work, and share ideas. This is a really important part of the engineering design cycle. So really quickly, let's think through the steps of what we did as we were thinking like an engineer. We got our problem. We knew that the turtle wants to make a vehicle that can go as fast as a rabbit in a fair race. Then we drew a little sketch. Then we gathered our materials and we made a model. We tested our model, made some changes, tested again. We made sure that we recorded our data after each test. And now you guys are going to do a final test, make some more changes, and finally you'll share your information with your classmates. And that's a really important part of the design process, is that sharing of ideas, getting ideas from each other, learning what works and what doesn't. So good luck, guys, and I will talk to you later. Have fun and stay curious.